Okay, this is the last part of chapter 1, part 3, and this is going to talk about some math stuff. So metric system, scientific notation, density, things like that. So we'll start out with a metric system, and the metric system is going to be based on the number 10. Oh, that's lovely. That totally makes sense, right? That means that we can kind of move the decimal place, and that's going to change our units. Now, that's different from the customary system, which is what we grew up with here in America, and in England they also use it. And that's how our whole system of like there's 12 inches in a foot and there's 3 feet in a yard, like really weird conversions and things. So the metric system makes a lot more sense, and that's why the metric system is used pretty much worldwide in science. So I've listed here all of the different basic units. And so you've got meters, liters, grams, seconds, and degrees Celsius. And these can all be the basic unit, and then in front of them we put a prefix. And you can see I've listed all the prefixes here and what they basically are equal to numerically. Now, sometimes we're going to need to do conversions. So let's say we have something that's, so many milligrams, and we want to know how many grams that would be. Then we have to do conversions. And there's a couple of ways of doing that. Once again, if you grew up with a metric system, this is going to be no problem to you whatsoever. So one thing that's important is to actually make an equality. So an equality is going to be like, let's say we were going from meters to centimeters. We know that 1 meter has 100 centimeters in it. And you can use that table that I just showed you to kind of help you figure that out. So when we do a conversion, we can use that, and I'll show you how to do that in just a second. But there's a couple of other ways you can do it too. So first thing is the way that I actually do it, and that's understanding the prefix of the unit. So I know that centi means hundredth, and so I can kind of go from there. Not the best way to do it, so I wouldn't exactly recommend that first one. The second one tends to be the one that I've found to be the most popular in all my years of teaching, and it's called the ladder or the step method. Super awesome. Just so you know, I will always have this entire thing that you see right here on any quiz or any exam that I ask you about this stuff with. So the way it works, let's say that we have something that is 0.2 kilometers, and we want to know how many meters it is. So here's kilo, right, kilometers. And then remember, basic unit would be meters because it doesn't have anything in front of it. So we want to see how many steps it takes to go from kilo to meters. So it's 1, 2, 3. And if you look at the direction we went to the right. So that means that we're going to move that decimal place 3 places to the right. So it was 0.2 kilometers. So if we move it 3 places, that would be 200, right? So that's how you can figure it out. So pretty easy. Wait, 1, 2, 3. Yeah. So pretty easy way to do conversions in the metric system. And we'll play with this in class as well. Another thing that you can do is using what are called conversion factors. And so here are conversion factors right here. And that's using that equality that we talked about, but putting it in fraction form. So 1 kilogram is equal to 1,000 grams. This says the same thing, it just has one above the other. So the way you'll figure out what goes above the other is with a problem that you do. And so I'll show you in this next example what I'm talking about. So when you do conversion problems, there's always going to be this setup. You're going to have your given, what the question tells you. Then you're going to have your conversion factor to get you what you need in the question. So a lot of times you actually do this without thinking about it. So in this first one, you've got how many minutes are in 2.5 hours. Okay, so let's go through this whole thing. They've given us 2.5 hours, and we need to figure out how many minutes, right? So here's our needed is minutes. So if we look at this formula again, you're going to take the given times that conversion factor to give us our needed. So now we need to figure out the relationship between hours and minutes, and we know that there's 60 minutes in an hour. So the way we set it up, we could have had 1 hour over 60 minutes, right? But the way we want to set it up is so that this hour and this hour cancel out, and then you're left with minutes. So that means putting the minutes on the top. So if we multiply across, we end up getting 150 minutes. So that's how you can do a problem using a conversion factor. Now, you can also do it a couple of other ways, and I'll show you on this one right here. So we've got a rattlesnake that's 2.44 meters long. How many centimeters long is a snake? So our given is going to be 2.44 meters, and then our needs is going to be centimeters. So we need to figure out relationship between meters and centimeters, and we know that there's 100 centimeters in a meter, so that's our conversion factor. So once again, set it up so that the meters cancel, and you're only left with centimeters, and just multiply across and get 244 centimeters. So that's one way that you can do it. You can also do this problem using the ladder or the step method. So if we go back up to that, we have 2.44 meters, which is our basic unit, and we want to go to centimeters, which is 2 steps to the right. So that means we would move our decimal place 2 steps to the right, and so that would be 244, just like we got with the other way. So there's 2 ways that you can do it. It totally depends on what works for you. But like I said, you'll always have that ladder or step method stuff up on the screen or whatever we use. Okay, next thing we're going to talk about is going to be density. Density is pretty interesting because it's just comparing the mass of an object to the actual volume. So basically how heavy something is in relation to how big it is. So let's say that I had a cup full of ping pong balls and I had a cup full of lead balls, and they're basically the same size. It's just that one is going to be less dense, right? Or if I had styrofoam or something like that. So that's what density is looking at. So the way you figure it out is you take the mass and divide it by the volume. And so the units that you always want to get to are going to be grams per milliliter, or you can do grams per centimeter cubed. Now that should tell you something. That means that a milliliter and a centimeter cubed are the same thing. So that's going to be what the answer will be in. So let's do this example problem. Pretty easy. Osmium is a very dense metal. What's its density in grams per centimeter cubed if 50 grams of osmium has a volume of 2 centimeters cubed? So to do this, you just do mass divided by volume. 50 grams divided by 2 centimeters cubed, and you get 25 grams per centimeter cubed. Perfect, right? Now, that's great when the question gives you the volume, but sometimes you have to figure out the volume before you can go any further. And this is something you're going to encounter in lab. So when you do that, sometimes it's easy because you'll have like some sort of formula, right? Like for this box right here, this is kind of a cube, right? And so I could actually look at, measure the length, the width, and the height, and I could actually figure out the volume of this box. However, if I have like this lamp right here and I want to figure out the volume of this, that's a little bit more difficult. There isn't like a lamp formula, right? So to do that, what you can do is what's called fluid displacement. And fluid displacement, obviously, we're going to talk about it on a smaller level. You could do it on a bigger level with the lamp. But anyway, what you could do, let's say that we were talking about like my keys, right? And I wanted to know the volume of my keys. So what we would do is we would fill up a graduated cylinder, which is those long, skinny cylinders. And let's say we filled it up to like 30 milliliters. And we dropped my keys in and it went up to 36 milliliters. You just subtract it, and that would be the volume of my keys, which would be 6 milliliters, right? So that's how you can do that, and we're going to do that in lab. Okay, so then the last part right here that we're going to talk about is going to be what's called scientific notation. So you've definitely seen this before, and the point of scientific notation is not just to give Bio 111 students homework problems, but to kind of control zeros. So like let's say I want to know how many miles away the moon is from the sun or something like that. That would be a lot of zeros, right? So it's a lot easier to actually put something in a scientific notation. And the way it's going to be set up is you're always going to have this coefficient number here, and then you're going to have a power of 10 over here. So what this means, this power of 10, is how many places the decimal is going to move and also what direction. So if it's positive, like here, that means that the decimal place is going to move 2 spaces to the right. If it's negative, like over here, that means that it's going to move 4 places to the left. Okay? So if we want to figure out what this number actually was, we would just move the decimal 2 places to the right. So 1, 2. So this is also the same as 350. If you go over here, then we've got 10 to the negative 4th. So we would move it 4 places to the left. So we've got 1, 2, 3, 4. So it would be 0.000725. Okay, so you can see over here we also did the same thing. So you can kind of see how scientific notation works. Once again, you're going to get some practice problems to kind of work on this, but I just wanted to show you this and kind of explain it a little bit more. And then what I did down here is just kind of showed you how big and how small numbers are related to their scientific notation. So that's it for chapter 1. Like I said, a little bit of an easier chapter, but it does get more difficult, so definitely watch these videos. I hope they help. And see you in chapter 2.